Hi, this is Almost Engineering and I'm Marcus. In this video we will be looking at the performance of the two most commonly used rifle calibers today. This would be the Nato 5.56 by 45mm round, often referred to as simply 5.56, and the 7.62 by 39mm round, which originated in the Soviet Union. So we are looking at the ammo most of the West uses and we'll compare it to the main ammo type Russia is currently using. Both calibers will be represented by their full metal jacket variant.
Full metal jacket.
Since expanding ammo, like hollow points, are illegal in warfare, because they are classified as inhumane. This is important since hollow points are designed to expand on impact and cause significantly more damage in soft targets. I want to show the impact behavior of both these rounds and will do that with the help of finite element simulations. While researching this video, I stumbled across a couple of scientific papers which compared those two calibers. These comparisons almost exclusively looked at the mass of the bullet, the initial velocity and the kinetic energy as their main technical criteria for the performance of the bullet. In theory, I would agree with these criteria, especially with kinetic energy, since that results from the mass and the velocity of the bullet. So the chosen criteria in themselves are a bit redundant. However, most of these studies seem to neglect the real behavior of a bullet when it hits its target. Very high kinetic energy is not worth much when you can't transfer this energy into your target. So if a bullet goes straight through, it won't cause significant damage and therefore will have insufficient stopping power. I would rather argue that the kinetic energy in itself is not a good criteria for assuming the effectiveness of a bullet. Rather, that the difference in kinetic energy the bullet has before it enters its target and after it leaves its target would be a good indicator for the effectiveness of a bullet. This energy transfer is influenced by the shape and the material of the bullet and its target. In order to account for that, I performed some simulations with the smaller and faster Nato round and compared it to the heavier and slower Russian round. Here you can see that I assumed a mass of 4 grams for the Nato round at a velocity of about 915 meters per second. And here you can see the specs I used for the Russian round. I assumed a weight of about 8 grams at a velocity of 738 meters per second. These specs favor the Russian round quite significantly since it has about 30% more kinetic energy to work with compared to the Nato round. The first simulations I ran were performed against a mild steel plate. In general, you would expect both rounds to penetrate about 10 millimeters or a quarter of an inch thick steel plate. Now this animation shows the results for the Nato round, and as expected it does penetrate the steel plate quite easily. And here you can see the results for the simulation with the Russian round. As expected, it also penetrates the steel plate quite easily. If you only look at the visuals, it appears that the performance is quite similar, with the slight exception that the Russian round makes larger holes. However, the curves which show the kinetic energy in each of those impacts tell a very different story. The Russian round has transferred a lot more energy into its target compared to the Nato round, which means that the Russian round damaged the target quite a lot more than the Nato round. If you compare the energies of the bullets after they hit the target, you can see that the Nato round has quite a lot more energy left in the bullet compared to the Russian round. So if your goal is to penetrate hard materials like armor or cover, the NATO round performs better in this simulation, and significantly at that. However, if your goal is to damage the first target you hit, the Russian round is quite significantly more effective. In order to verify that my simulation parameters are good, I also performed a simulation against a 20mm thick steel plate. You would expect that both these bullets are stopped by steel plates of this thickness. My simulation also showed that this is the case for the NATO round, as you can see here, and for the Russian round, as you can see here. Now, when you compare the energy outputs in these simulations, a very different story is evident. Since both bullets transfer all of their energy into the target, the Russian round performs significantly better. This is due to the fact that the initial energy it has is about 30% higher than the energy that the NATO round has. Usually you do not try to kill steel plates, so I substituted the material model of those with a material model that resembles human soft tissue and performed simulations with that. The results of these simulations can be seen here. The first thing that is obvious is how much faster the NATO round moves through the target. The second thing that is obvious is how much faster the NATO round stops compared to the Russian one. This is due to the fact that it has so much less energy than the Russian round, and therefore the Russian round does penetrate further and causes in total more damage to the target. These simulations also show that almost all of the energy is transformed into the target by both rounds. This also gives the edge to the Russian round, which can do more damage with the higher amount of energy it has available. So far I have shown that the NATO round has an advantage when it hits a target behind cover or a target which wears armor, but the Russian rounds perform better when you hit soft targets with it. Finally, I wanted to know if a NATO round would profit more from an increase in mass or an even faster initial velocity. On the left side of the screen, you can see the penetration depth of a 7.62 round and a 5.56 round without any modifications. If you increase the mass of a 5.56 bullet to match the mass of a 7.62 bullet, you can see that it performs slightly better than the Russian round. However, if you increase the speed of the NATO round to match the energy that the Russian round has, you effectively decrease the penetration depth of this bullet. This is most likely due to an effect called strain rate effect, which means that a material gets significantly harder the faster you hit it. So even though you have the same amount of energy in the speed scaled 5.56 bullet compared to the 7.62 bullet, it does not achieve as much penetration depth than the Russian round. So in conclusion, I can say that the Russian rounds do perform better when hitting soft targets. However, the impact behavior of a bullet is not the sole reason why you want to choose it. So the overall weight of the magazines and the ballistic coefficients and things like that also play a role if you choose which caliber is right for you. And most of these factors seem to favor the NATO caliber over the Russian caliber quite significantly. And with that, I want to thank you for watching and leave a like or subscribe to my channel for more engineering related content.